Okay, let's dive right into this. Welcome, everyone. I am incredibly excited to have you here for today's explainer because we are going to tackle a concept that frankly completely breaks the human brain. We're talking about the fourth dimension. Now, don't worry, we're not going to get bogged down in unapproachable, heavy academic jargon. Instead, we're going to build our understanding logically, step by step, starting from the ground up. So let's start this bottom-up mathematical journey and really stretch our minds a bit. So, here's our roadmap for this explainer so you know exactly where we're heading. First, we'll cover building the basic dimensions. Second, the problem with perception. Third, visualizing the fourth dimension. Fourth is time the fourth dimension. And finally, we'll wrap up with the infinite curve theory. All right, part one, building the basic dimensions. Basically, stacking up reality. To start, I want you to picture a simple folder sitting on your desk. Now, imagine that folder is a dimensional plane with absolutely no height and no depth at all. It is literally just a straight line. That is a one-dimensional or 1D world. If a little organism lived there, it could only move in a strict linear path, just straight forward or straight backward. That's it. So how do we jump to the second dimension? Well, a 2D world is made up of an infinite series of those 1D lines stacked right on top of each other. That gives us a flat plane with width and length. A creature living there can move up, down, left, right, and anywhere in between. And building on that exact same pattern brings us to our reality, the third dimension. Just like stacking lines made a plane, stacking an infinite series of 2D planes upon each other gives us a 3D world with depth, length, and width. This is a cube. This is the world we live in. Moving right along to section 2, the problem with perception, or why we don't actually see our true world. It's wild to think about, but what mathematically exists out there isn't always what we literally see. Take our own physical reality, for example. We live in a 3D world with actual physical depth, but our eyes actually view things two-dimensionally. Think about a perfect sphere. If you just look at it without any context, it basically looks like a regular flat 2D circle. The only reason you know it's a sphere with depth is because your brain is analyzing the hues of light hitting it, lighter on one end, darker in the middle. Furthermore, when an object moves closer to you or farther away, you don't instantly perceive that physical depth. You're just seeing a 2D image getting smaller or larger, and your brain is doing the math, assuming that size change means it's changing distance. Now, what's really fascinating here is how this perception problem applies downwards. If we as 3D creatures perceive our world in 2D, what happens to an organism living on a flat 2D plane? Well, following the logic, they would only be able to see in one dimension, just flat straight lines. Imagine a rubber band expanding while simultaneously moving farther away from that 2D organism. If that rubber band grows in perfect equilibrium, meaning it expands at the exact same speed that it shrinks visually as it moves away, that 2D creature wouldn't be able to tell it's moving or growing at all without light cues. They completely lack the depth perception to understand what is actually happening right in front of them. So the big takeaway here is absolutely crucial. Creatures always perceive the world exactly one dimension lower than the one they actually exist in. Which brings us to section 3, visualizing the fourth dimension. Let's talk about the tesseract and get to that real wow moment. So let's walk through this strict logical progression of mathematics, what we'll call the rule of +1, to see exactly how a 4D shape is built. Step 1, we take that 1D straight line. We connect 4 of those lines so that the adjacent sides are perpendicular and the opposite sides are parallel, and boom, we get the basic shape of the second dimension, a square. Step 2, we connect those squares together using those exact same geometric rules, and we end up with the basic shape of the third dimension, a cube. So step 3, logically, if we just keep following this exact same mathematical pattern and apply that rule of +1, we connect 3D cubes together, and doing that forms the basic shape of the fourth dimension. And we call that specific shape a tesseract. Essentially, think of it as 4 cubes within each other, with all adjacent sides perpendicular, opposite sides parallel, and 4 lines connecting to each vertex. Now, I have to reassure you right now, if you are completely struggling to picture this in your head, that is perfectly normal. You physically cannot picture a true tesseract in your mind. Our brains are hardwired for a 3D world, so we literally lack the biological hardware to process what a 4D object actually looks like. Anytime you see a 2D drawing or a fancy computer model of a tesseract, you are just looking at a distorted shadow of the real thing. It's impossible to show its true form because the lines in a real tesseract wouldn't be visually distorted to us at all. They would be perfectly straight, just in a physical direction we literally cannot see. Okay, here is what I consider the absolute mind-blowing wow moment of this entire concept. Think back to our perception rule from earlier. We are 3D, so we see our world in 2D. That means a 4D creature would look at our universe and see it in true, perfect 3D. They could literally look past our 3D walls and see straight inside locked houses. They could even see inside our bodies, meaning a 4D entity could literally watch the lunch you just ate digesting in your stomach right this very second. Think about it. Just as you can look down at a flat 2D piece of paper on your floor and see everything drawn on it all at once, a 4D creature looking down at our 3D world could see absolutely everything simultaneously. To them, the inside of a closed 3D box is completely exposed. No secrets. It is just mind-blowing. Let's pivot to section 4. Is time the fourth dimension? We need to debunk a super common misconception here. I know exactly what you are probably thinking right now. You're sitting there wondering, wait a second, isn't the fourth dimension just time? People say this all the time, right? They argue that moving forward and backward in time is basically just like moving in a spatial dimension. But is it? Let's dig into that. Let's logically dismantle this myth piece by piece. First and foremost, time is not spatial. There's a huge, very obvious difference between physical space and time. Secondly, if we assume dimensions follow the mathematical pattern we just established, calling time the fourth dimension makes absolutely no sense because every single dimension has time in it. A 1D line experiences time. A flat 2D plane experiences time. If time were the fourth dimension, it would mean the fourth dimension is somehow uniquely special, which completely breaks the entire mathematical pattern we literally just built. And finally, consider astronauts. If a group of astronauts get into a spaceship and travel incredibly close to the speed of light for a few months, when they get back to Earth, they'll find that Earth has actually progressed a few years. They literally traveled through time. But, and here is the kicker, they didn't suddenly enter a brand new spatial dimension to do it. Time just behaves differently at incredibly high speeds, but it definitely doesn't give them a new physical direction to move it. All right, our final section, number 5, the infinite curve theory. Basically, where does all this end? A lot of physicists and mathematicians suggest that nothing in reality can be truly, absolutely infinite in a perfectly straight line. So let's trace out what that actually means. Imagine that the first dimension, that straight line, is actually very, very slightly curved. If you follow that line for a massive, incomprehensible amount of distance, it will eventually connect back with itself and form a circle. The exact same thing happens in the second dimension. If a flat 2D square is extended infinitely, it very slightly curves until it forms a 3D sphere. So following this pattern, what happens to our dimension? Well, it means that our 3D space is likely very, very slightly curved as well. And if you travel far enough, it will eventually wrap completely around to form a 4D universe. It's like a giant cosmic loop. And that leads us to this incredible concept of the Russian nesting doll universe. If this curved space theory is true, it means that our entire three-dimensional world exists completely and entirely within a four-dimensional world. And logically, that four-dimensional world exists completely within a five-dimensional world, and so on and so on. We are basically just a tiny nested doll sitting inside a much higher, complex reality that we literally can't even perceive. Which brings us to a final, slightly terrifying question I want to leave you with today. If the math implies that dimensions are just infinitely nesting inside of one another, 3D inside 4D, inside 5D, inside the 71st dimension, curving and wrapping around forever, is a true never-ending infinity actually possible? Does this pattern ever stop? Or is reality just an endless, impossible loop of higher dimensions layered on top of each other? It is a question that completely challenges the very limits of our reality. Thank you so much for joining me on this mind-bending mathematical journey today. Keep questioning, keep learning, and I'll see you in the next explainer.